Storage is critical to any computer system these days, especially servers. And there's some new technology that everybody's starting to use called MRDIMMs. So, Alan, could you tell us what are MRDIMMs and why are they important?
Definitely. Thank you so much, Bill, for your time and appreciate it. MRDIMMs basically, or the multiplex rank DIMMs, is the next evolution of DDR5 server memory. And it's designed to deliver significantly higher memory bandwidth without requiring a complete redesign of server platforms. But in order to understand the importance and the need of MRDIMM, we have to kind of look at the industry and the data center growth and the needs of the data center. AI, cloud, and HPC workloads are growing faster than memory bandwidth. And as they continue to do so, processors increasingly become limited by how fast data can move between the memory and the compute. MRDIMM helps and comes into the picture here and helps remove that bottleneck by increasing effective memory throughput while maintaining the compatibility with the standard DDR5 server architecture. So the traditional memory architecture are approaching practical limits and how much bandwidth they can deliver. There is where MRDIMMs play a critical role and use the intelligent multiplexing technology through devices such as interface devices such as the MRCDs and MDBs, which Renesas offers, to increase data transfer efficiency, as well as to achieve much higher performance than the conventional DIMMs in the industry. And what does this do to the system? It allows system designers to continue scaling memory performance without fundamentally changing their motherboard, processor, or even the DIMM form factor, depending on which area they work. So MRDIMM is one of the industry's key innovations for addressing this bottleneck and keeping processors and accelerators fed with the data that they need.
You've been talking about some of the advantages of MRDIMMs. How do they differ in terms of implementation with respect to RDIMMs?
As I talked about in the previous question, it increases the bandwidth per memory channel by accessing multiple DRAM ranks in parallel and using the MDB, the data buffer, to multiplex the data streams, which in turn increase the bandwidth up to 2 times without any additional CPU memory channels and improves the efficiency by 18 to 20%. The other advantage is that the MRDIMM feeds growing CPU core counts by delivering more data through each channel, which in turn helps keep more core utilized instead of waiting for memory and prevents memory bandwidth from becoming the bottleneck as core counts continue to increase. The MRDIMM improves the signal integrity at higher speeds. You know, we talked about speeds reaching up to 16,000 mega transfers per second. These are very high speeds, right? And once we are hitting those speeds, you're going to start thinking about signal integrity. And what MRDIMM does, and then the MDB specifically on the MRDIMMs, they buffer the command and address and data signals respectively, enabling the operation and signal integrity at higher data rates. The other advantage of the MRDIMM is that it expands capacity per DIMM slot by supporting additional ranks, which allows greater capacity without addition of any memory channels, which you have up to capacities up to 256 gigabytes, 512 gigabytes, or even higher per memory DIMM, allowing the capacity scaling per system. And the MRDIMM reduces the loaded memory latency by up to 40% and offers effective bandwidth versus the RDIMM in select configurations, especially because on the MRDIMM you have the 10 DDR5 MRDIMM, you have the 10 data buffers buffering the data signals. The other advantage is that it improves the data center efficiency by higher bandwidth capacity and performance per watt. The workload consolidation is improved, and it offers 2 times bandwidth per socket which in turn unleashes higher data center throughput, optimized memory usage, and system scaling, specifically in AI and inference, HPC, and other bandwidth-hungry applications. And lastly, it maintains the familiar DIMM form factor and leverages the existing DDR5 ecosystem, which enables the server manufacturers to achieve greater performance without disruptive architectural changes to the boards, to the DIMMs, to their design. So it fits in right perfectly to into the existing ecosystem and designs.
Oh, very good. Now, Renesas is releasing their Gen 3 version of their MRDIMM controller. Could you tell
Yes.
us a little bit about some of the new features and performance?
Definitely. Yes, we are releasing our Gen 3 MRCD and MDB, which, based on the previous answers that I gave in question 1 and 2, by now we know how important an MRCD and an MDB component is when we talk about the MRDIMM.
Hmm.
So, from the market, first of all, from the market and industry point of view, Renesas is the only complete provider for all DDR5 MRDIMM memory interface content. So what are those contents? First one is the MRCD, the MDB, then you have the SPD hub, you have PMIC, and then you have the temp sensor. So these 5 components are on a DDR5 MRDIMM, and Renesas has all of them. But what's specifically new here that we're talking about today is our Gen 3 MRCD and Gen 3 MDB components, which as a chipset together, they deliver 25% higher memory bandwidth than compared to the previous Gen 2 MRDIMM. And our chipsets preserve the standard DIMM form factors and system compatibility. We have also introduced system visibility and robustness enhancements features. Specifically, one of the features is called the Device Equalization Self-Trained Mode. In short, they call it DESTM, which basically enables the users to fine-tune timing and receiver equalization training to maximize the margins. So we talked about speeds reaching up to 16,000 megatransfers per second. So, and as speeds reach that high, the electrical signals traveling between the CPU, the MRCD, the MDB, and then the DRAM become very difficult to distinguish cleanly. Even small variations in trace lengths, temperature, or even voltage, right, can cause data errors. So what DESTM, this feature does is basically, so during the system initialization and training, the memory devices send special training patterns. Then the receivers test different equalization settings, such as, say, signal cleanup settings. And then the system determines which settings provide the biggest timing and signal quality margin. And then DESTM reports a quality indication status showing how well the link is trained, which ultimately increases the system visibility and robustness to the user. So these are basically some of the product and features that we're offering in Gen 3 space. Looking at the ecosystem and the market, we're also actively, and in this case, very proactively, working with our ecosystem partners on all fronts. These ecosystem partners include CPU providers, memory vendors, and even our end customers that are, cloud guys or OEM suppliers, as well as we're leading the efforts in the standardization communities on the memory spec standardization to ensure product qualification, deployment, and wide adoption in the industry, adding to the great successes of the previous product. And finally, we are currently sampling our Gen 3 MRCD and MDB in the engineering sample stages, and it's in the very first stages, while the other 3 components, the PMIC temperature sensor and the SPD hub, are already widely available and in mass production and used in other DDR5 DIMMs such as RDIMMs as well.